Alright, so let's see, this is basically a quick little vocab review. You should be able to identify these based on pictures or come up with them, but acute, less than 90, right? Smaller than 90. So there's a picture that works for it. Right angle, which would be equals 90 degrees. Obtuse, and we'll go with more than 90 with the definition that we used for angle so far. That works. And straight, sort of a weird one, so that equals 180. So the reason I said we'll go with more than 90, technically obtuse would be more than 90 less than 180, but that's okay. For right now, we're only going to go for angles between 0 and 360. We will see later in this chapter that you can have negative angles and angles larger than 360, but we'll have to change our definition since most of us did it based on lines intersecting and the space between these things. We're sort of stuck between 0 and 360. Okay, then you have complementary angles. So this is a pair, right? So these are relationships between, and then it's usually two angles, although we could sort of tweak this in word problems and give you a whole bunch that are complementary. So complementary means that the angles add to 90. Yep. So 30 and 60 are complementary. Supplementary would be when the angles add to angles and to 180. So 135 and 45. In conjugate, we don't use it a whole lot, but the book uses it as a term, and that will be when angles add to 360. For example, these two angles. And you'll most likely see these in small little word problems or just problems actually that you'll see here on the next page. So can I move on? Okay, sorry about the blurriness there. So let's say that that's 35, so that's a 35 degree angle. And then that's 20, you can see that. So how can you find angle B? I cheated a little bit.
Add both of those together and subtract them from 180.
Right, because in a triangle the angles always add up to 180, right? Okay, so this is what I meant sort of with word problems and that kind of stuff. So triangles our angles add to 180 degrees always. So what you get here is 180 minus 55, which would be 125 degrees, I think. Are we okay on that one? Okay, how about this one here? So we clearly know this symbol, right? That means this is a 90 degree angle, right? So angle D would be what? Two ways to get it.
37 degrees.
Right? And how did you do that? I don't think.
Added 90 plus 53.
Okay, so you did it the same way. So that would be one way to do it, which is to add 90 and 53. And then you subtract that from the 180. So that's 143, and that's 37. What I probably would have done here would be to say, well, angle D must be then 90 minus 53. Because if that's given as a 90, then you know the other two have to add to 90, the whole complementary, supplementary type of thing. And 90 minus 53 is 37 still. So two ways to do that. I don't really care how you do it. Okay, how about the last problem? So it's a little blurry. Those are actually alphas, and alpha is the Greek A. So the symbol for that is a little bit like a fish. So that's alpha. So how do you find this one? How do I find out what angle X and Z and Y are worth? So how many alphas do we have?
3.
well, we got 3 here,
5,
4, 5. So all of these add up to how much?
180.
180. So that means that one of them must be whatever that is, right? 180 divided by 5. That's 36. So angle X and angle Z apparently are 36. That still leaves you with angle Y. Angle Y must be how much then? You can do 3 times 36, which is 108. Or you could have done the 180 minus 36 and 36 is 72 and all that. It's probably faster to do 3 times 36 here, isn't it? Okay? So that works. We're good? So I like pictures, that they work better for me. These problems could also have been done this way. Basically, these are almost the same problems, but different numbers. So if A is 15 and C is 40, what do you do to find B? Well, you do 180 minus the 15 plus the 40. So that's 180 minus 55. Well, I guess 15 and 40 adds to 55, just like the first problem. So that's another 125, right? So if A equals B and C is 70, then how do you find out what A and B are? Keep in mind,
Subtract 70 from 180, then
Mhm.
the remainder of that too.
so if A equals B and C is 70, then you know that A plus B equals 180 minus 70. So A plus B is 110. Thank you, you're way ahead of me. So yes, I'm gonna end up with 55, not 60. So you have 110 degrees between the two of them, and you just need to divide by 2 because they're equal to each other. So A is equal to B, so both of those will be 55 degrees. Okay, now the last problem, so actually problem 2 was similar to the third problem in terms of pictures. 3 is the right triangle problem. So you have a right triangle with C as the right angle and A is 12, find B. So what I would do to find angle B is, I know that the other two add up to 90, so it's 90 minus 12, which would be 78. So these are just little word problems type of stuff to get you familiar again with dealing with angles, complementary, supplementary. Although most of that, I'm not really going to ask you, hey, 2 angles are supplementary, one is 30, find the other angle. It'll be in terms of a triangle problem or a rectangle or something like that. Alright. All that should have been mostly review. So now let's look at what's a little bit new. So here is one proof of Pythagorean Theorem. And I think you should be able to do this proof. So let's draw, and this was a right angle. Let's draw another right angle this way. And then no. Guess, is that what you guys have printed, or did I change it? Do you have A, C, and B this way? Because it doesn't matter, but
Yeah.
you do? Okay. I messed up a little bit here. So this should be C, because in this thing the C stands for hypotenuse, right? So the C needs to be across for the angle. So keep in mind, hopefully you remember that a little bit. So the angle and then the side across of it are labeled the same way, and then we'll call this one A, and I need to fix that, and then means that this side is little a, and if angle B is here, then this side is little b. So what I created here was a new point D, and then we'll just call this little d from here to here, which is sort of doesn't jive at all with what I've labeled it so far. And then what do you know, if from here to here is little d, then from here to here is how much? What can I write there? Because you know that the whole thing is what? So if the whole thing is C, then right now I have C minus D left over here, right? Are we okay with that? Yes, no? We're good? Okay. So now I'm going to lift out these little triangles that I have here. So the first one I'm going to lift out is this triangle BDC, but I'm going to flip it also so that it's sitting with the right angle down. So this is the right angle. That would be D. And B is just above it because it's the shortest distance. And this must be point C over here. So this is C. And then let's level. So from between B and D is called D. From D to C, I don't really know that yet. And from B to C is called A, right? Yes? Okay. What do I know about triangle ABC and triangle CBD? What do you know about these triangles? Keep in mind that angle B is here and angle B is also here. So this angle is exactly this angle, right? And because this is 90 and this is 90, what do you know about this angle here? This angle must be the same as? Yeah, this angle here, it's got to be this angle here. That means that these two things they're not exactly the same, but they are similar, right? And this is the symbol for similar. You okay with this? Yes? No? Okay, based on those triangles being similar, I know that the hypotenuse, C, well that would be A in the little triangle. If I divide that by A, then in the little triangle, side A is actually D. Is that right? Do you guys see how in the big triangle, the long side, C divided by the short side, is A divided by the short side here in the small triangle? You guys okay with that? And then we're going to multiply this out, and maybe now you see why I did it this way. So that would give you that A squared is equal to C times D. Okay, so now I have found this term over here. And I can't find my marker right now. Okay, so what I have is this one. You okay with that? That leaves me with one triangle left that I can pick out. I can also take out this triangle here, which still D has the right angle, but now I'm taking the slightly bigger one. So that's D. So from D to A is where my right angle is, right? And then that must be C. So here's the other triangle that I created by drawing that first one. Okay, now angle A is the same here, and we know that D is right. So that means that this C is actually the same as angle B in the right triangle. So again, we can make two congruent triangles. Not congruent, similar. So we again can sort of show that in triangle ABC, which is the original triangle, is similar to triangle ACD. Are you guys okay with that? Alright, the distance from C to A we labeled as B, and this one was C minus D. This is sort of a little trickier because we have C minus D here. So now I'm going to do the same thing, but now I'm working on getting an expression for B squared. Okay? So C over B, so we're going to start the same way. So side C divided by side B in the original triangle is the same as the hypotenuse here, which is B, and then the basis, which is C minus D. So now I can write then that B squared is C times C minus D. So I can write this cross product. Okay, so now I have an expression for B squared. Now I need to clean up that right side a little bit. I need to clean up C squared, or this mess. So what can I do there? So I can do this. B squared is C times C is C squared minus CD. Oh. Okay. You see how I distributed that? What do we know about CD? How much is C? Huh? That's a B.
It's a B?
Yes. The distance from C to A is?
Oh, equals B.
Yeah. It's C to A now, right?
Yeah.
Okay. What can I write instead of CD? How much is CD worth? Yeah, isn't a squared equal to cd? So instead of writing that, I can write b squared is c squared minus a squared. Move this over, and you'll get a squared plus b squared is c squared, which proves Pythagorean theorem. Just one way that you can prove Pythagorean theorem. Okay? Based on similar triangles. Do have to keep in mind one thing with Pythagorean theorem. Does it work for any triangle? No, it only works for? It's right. It's only for right triangles. So when you do a problem and you want to use Pythagorean theorem, you better make sure that you use a right triangle. Okay, you'll see that in some word problems. I'm just sort of front loading you there. Keep in mind this only works for right triangles. Alright. So now we're going to find some stuff based on Pythagorean theorem in triangles. So how do you do that? So if you have this triangle and we're missing A, how can you find out what A is?
You gotta put it together.
Well,
So A equals
okay. And once you do this, you can sort of skip certain steps, but let's just write it all out for right now. So A squared is equal to 16 and 25, right? So that means that A squared is 25 minus 16 is 9, right? So A must be 3. If you know that a 3, 4, 5 is a, because that's sort of a given, it's Pythagorean triple, right? We heard of that before? Where all the sides are whole numbers, it's called a Pythagorean triple. Okay, so, and it's a, if you recognize that, you don't have to prove this one to me. So this is called a Pythagorean triple, where all the numbers are whole numbers. Okay, there's a word problem that, or there's a problem that will deal with that in your homework. Okay, so how about this one here? Well, here I don't think I know a Pythagorean triple with 12 and 14. I know one with 12 and 15, but not with 12 and 14. So here, same thing. You just do x squared plus 12 squared. And this is something that you learn that, like, I usually don't write the squared parts. I usually do write this, because sometimes I mess up on my what goes where. So when you subtract this, you get 54, right? Or 52. Yes? So that means that x would be the square root of 52. Okay. The way this problem is given, you would not want to take this square root on your calculator. So don't type this into the calculator and say it's about 7.2, because that's an estimate. So that would work for a word problem, because heights are usually not expressed as square roots. But in this case, I would expect you to write the square root of 52, although we recently learned that you should be able to reduce that, right? 52 is 4 times 13. So I would want you to reduce your square roots here. So you would write 2 square root of 13 here. Okay, so please don't write the square root of 52 anymore. See if you can reduce it. If you can see that it's 4 times 13, you can sort of skip a step here. Otherwise, you would have to sort of do it the long way, which is 52 divided by 2 is 26, divided by 2 is 13. So you got the same answer. Yeah? How about the last problem? Well, it's important that they told us it was 90, so that we can do that 17 squared is equal to 8 squared plus 8 squared. Okay, so 17 squared is 289. And that's 64. And then you get 8 squared is minus 64. So that's 225. 225, I said. So h would be, the square root of that would be what? 15, isn't it? So that happens to be another Pythagorean triple, which I didn't know this until I put this one together, and I did it earlier, but sometimes you run into triples without really knowing that they are there. Okay?